Round of applause, please.
Okay. So, hi everyone. Thanks for joining my presentation. I'm Mike, and in just about 45 minutes, I'm going to show you how you can save days or even weeks of unnecessary work by building better domain models using domain experiments. Okay, so without any further delay, let's start with some story. A story of some project called Crowdsourcery. Crowdsourcery is a crowdfunding platform supporting passive investing. And Crowdsourcery had a great team of experienced developers that used all of the best practices, test-driven development, domain-driven design. They were focused on creating clean code and clean architecture and applied best infrastructure practices. So it seems they had to succeed. And the result was unfortunately something like this, a total failure. Why did it happen? So mainly because we don't know really what we need up front, right? When we just got an idea, we don't know what we need to build. So the main point is that building software is all about learning and experimenting, learning about the domain, learning about the business, learning what we need to do, what we need to build to support the business. Okay, so this particular team failed because they didn't realize about it. They were focused on technical stuff and building a lot of prototypes to validate next ideas. And the idea of building a prototype seems great, especially for a startup, right? But there's one problem with prototype. It's usually quite costly to create next iteration of a prototype because you need to be aware of all the infrastructure details, everything, including application layer, user interfaces, that kind of stuff. You need then to run it on some staging or some separate production and check on users. So the problem is that it's slow, costly, and feedback loop about the domain, about what you're building, about your goals, is simply too slow. Okay, so maybe let's get back to the basics. Why do we even write software? Yeah, might be. To write some funny functions, something like that. Okay, to solve problems, yeah? We should, at least. Specifically, we are usually solving business problems. And if I were to summarize in 3 points why projects fail, I would say the first reason might be CV-driven development, yeah? We all did this, probably. But sometimes it might be a lack of technical skills, yeah? But I don't believe that's the main reason. However, the third point is usually the main reason why projects are failing. Because we are learning too slow, yeah? We are not adapting fast enough to the changes, to the requirements, to the market changes, to the business changes, to new features, yeah? That kind of stuff. And we are simply not fast enough with next iterations of our domain models, and we are not incorporating new domain findings into the code. So what can we do? Yeah? There must be something we can do about it. Yeah? And again, the answer is obvious. We need to learn faster. We need to iterate faster. But how can we do that? What's the best way to learn? And I think the best way is by practice and by experimenting. Yeah? All the practical science are all about experimenting, about learning by doing. Yeah? And when you're learning something new, you usually learn the most when you're working on concrete examples, trying new stuff, trying to build something, not just listening, yeah? Just like this presentation, yeah? It's better to build something than just listen to presentations. Okay, so I said it's all about experimenting, right? About building, trying new stuff. But how can we run these experiments in code? As I said, prototypes might be a good idea, but they're simply costly, and the feedback loop, so the learning rate, is too slow. So instead, we can run these experiments directly on the domain model of our software. Okay, so how can we run these domain experiments? I divided domain experiments into 2 categories. The first one is something I call initial experiments. And you run these initial experiments when you're building something new or working on a greenfield project, create a new feature in a module, something separated, something new, something fresh, shiny. And then you get life experiments. And life experiments are basically iterating on an existing solution. So mostly when working on legacy software, when changing some stuff, when confronting the upfront decisions made somewhere in the past. Yeah? So that's about life experiments. And because of the time limitations, I'm going just to show the initial experiments, because the flow is almost the same with some differences. But we can talk about running life experiments during the break if you want to. OK, so let's focus on the initial experiments, working on the greenfield. Yeah? So how do we run these initial experiments? I usually start with the example mapping. When you're trying to take some stories, some scenarios, and then write concrete examples how the system should behave. So kind of similar to the BDD approach, but not necessarily with such much discipline. Then we adjust the model to these examples. So the model that is emerging corresponds well to the examples. Yeah? And we can write these examples as unit tests. Yeah? I'm going to show it in a moment, how we can do that. Then we verify the model. And the name I came with is something I call cold storming, might be a good name for this step. We are basically trying to break our model, to challenge it, to check if it really suits our needs. Yeah? So we try to challenge, to break it. Then we ask others about challenging the model. So and finally ask everyone for a review. So in this step in the code storming, actually, that's the case where mob programming might actually work. I'm not a fan of mob programming, but that's the case where it might work, because we need to share the knowledge. We need to iterate faster, yeah? And we got nothing. We are just working on something new. So this is extremely chaotic, but at the same time, the learning is exponential to the team. So the case with domain experiments is that domain experiments can help you only if the feedback loop is quite short. So if you're creating pull requests to run experiments and ask for reviews, then this pull request shouldn't last longer than 1 day. And at the same time, you need a good team. So if your team is unwilling to learn, if they're afraid of challenging upfront decisions, then this won't work. So you will all waste your time, because you will try to introduce something new, change some approach, but if team is not ready for this, basically domain experiments won't work. OK, but finally, if experiment is accepted, you should keep track of the model changes. You can use architecture decision records for this to record it. You can write it in Markdown files, have a separate repository, keep it in the same repository. It's up to you, it doesn't matter. The point is that you need to write down what were the decisions made during this experiment. Yeah? And it might be especially interesting later on when someone tries to challenge the decision we've just made, and might think that, OK, so I need to change this model because it doesn't work like it should. But then you have the ADR, which tells, OK, we actually considered this change, but we didn't do this because of that and that, right? So it's usually a good idea to track it. OK, and I said we start with the example mapping. And why the example mapping? Yeah. So as I said, there's no better way to learn by examples, right? And the other reason is that because these examples actually help you to clarify the requirements and even help domain experts and the business stakeholders to actually understand their job, their project better by working on concrete examples. Yeah, that constitutes some kind of ubiquitous language. You are creating a language which is used through the company. So the thing is, when you combine example mapping with test-driven development, well, that's where it really shines. And I'm going to show it how we can go with domain experiments. There is a repository. It's publicly available. You can check it out later. But now I'm going to do a little live coding, starting from nothing. So I'm going to show you how we can run first stages of the initial experiments. OK, so first of all, if we are working on a griffin or something new, usually we got nothing. Yeah? Maybe we got some vision document, some blur vision, what we want to build. So let's start with this. Let's imagine there is some document about the vision of the crowdsourcery project. And there is usually a motivation, yeah. So for instance, active investing requires a lot of time. Investors usually don't have that much time. And portfolio diversification is essential to secure your returns. So we want to create a crowdfunding platform which supports automated and passive investing. So that's our value proposition, yeah? Crowdsourcery allows investors to invest into any kind of asset. Borrowers then repay loans. Crowdsourcery is a fundraising platform which allows investors to allocate their money passively into a group of assets using automated strategies. So that's our value proposition of the project. And the very, very initial requirements, naturally simplified for the needs of the demo, are just 4 requirements for now. So the first requirement is any borrower can start the fundraising to finance her project. Then investors can invest into assets. Investors receive returns based on the asset they invested in, and borrowers receive funds to finance their project based on the schedule. So these are the initial requirements. And what I do before I get to the example mapping, we need to start with something. Yeah? We got vision, but we got nothing except the vision. So it will be hard to start with just the examples immediately, with the example mapping. So instead, I usually start with the big picture session of the event storming. Yeah? Most of you are aware of event storming. If you're not, the idea is you group a lot of people and you let them post stickies about interesting facts in the domain. At least that's how the big picture works. So the idea is we need to map out the needs, find out what's happening in our domain. So some facts that are happening, some domain events which are happening here are like project funded, investment made, project defaulted, funds received, schedule accepted, project repaid, interest paid, investor registered. And basically a lot of people come in and just post these stickies here. There would be a lot more. There might be 100, 200, 300 of stickies in just about, I don't know, maybe an hour or 2 hours, depending on the volume of the team, depending how interactive they are. But the idea is that everyone just posts something which thinks is interesting. So we are not focusing on a specific process. We are not focusing on a specific subdomain. We are just trying to map everything, what's interesting and what's happening in our domain. OK. So after big picture, there are a lot of techniques. There are some. There are pivotal events. We can use swim lanes and other kind of stuff to try to structure these events according to the timeline and group them into some kind of clusters which tell a consistent story. But I skipped this part and instead already mapped these events into two processes. The first process we found out was fundraising. The second was investing. Yeah? So fundraising is something like borrower register. The borrower is registered, then schedule can be accepted, then project can be started, project can be cancelled, or funds can be received. Finally, project can be funded. Yeah? So from the left to right, it's ordered by time. And we will focus just on the fundraising now. So the next step would be to actually try to find concrete examples. Yeah? A lot of people go to the, after process level event storming, a lot of people go to the design level event storming when they try to tell, OK, so we have commands, we have something which accepts these commands, something which produces events, and that's called design level event storming. What I propose is to skip design level event storming on stickies and go directly to the code. So instead, I go with example mapping, and then I'll try to translate these examples into tests directly. There are a couple of stories here. The first one is, for example, starting a project. Yeah. Starting a project, and now you see the green stickies. The green stickies are actually examples. These examples don't need to be necessarily described as in BDD, so not given, when, then, or some scenarios. You are just given a rough description of a concrete example. So, for example, you usually read it in the third person. So, the case where adult borrower starts a project. That might be the first one. Then, the borrower, the one where borrower without criminal records starts a project, yeah? Or okay when less than $10,000, or need to be verified manually when it's worth more than $10,000. The one where schedule is accepted, the one that was schedule is not accepted. And sometimes we might want to, just based on these examples, to find out the rules. The rules might be written on the blue stickies here. So, for example, the first rule might be only verified borrowers are allowed to start a project. The second one is project must be verified, yeah, before starting. So, but what I do is I usually start with the examples, and I let to find out the rules later. Some people like to tell the rules first and then examples. I usually go the other way. Okay, so now the important thing is that we got just this. And what I do now, I take some example of starting a project, and I'll start coding it as unit test without having absolutely nothing. So I switch to my IDE. You see there is nothing yet. There is just some application class generated, bootstrapped by the system. And since we have nothing, we need to start with something interesting. So let's create a new test. For example, starting a project. Okay. I am using Jupyter here, so I usually give names in the display name. So something like starting a project examples. Yeah. Okay. So we got nothing. And we will start with the very first concrete example. Yeah? So we said that adult borrower can start a project. Yeah? So we can start with this, or even just with that, borrower starts a project. We might not be thinking about all the details yet. So borrower starts a project. Yeah? Okay. So start. Got nothing. But what we might do, we might start producing stuff according to the examples, and our code and domain model will emerge. So that might be something like this. Borrower, we got no borrower, so let's create one. Okay, and switch back, yeah? Okay, then we want to start a project. So we need something which accepts starting a project. Yeah? It might be just a function, but let's just focus to the basics of Java. So we need something which accepts it. So let's say that might be, I don't know, start project system. The name is really not important. Albert Brandwell says you can give absolutely any name to it at the very beginning, and then you can find out what's needed. So again, we create it, yeah, okay. And what we do now is we say that start project system can actually accept the command start project, right? Start project by, for example, the borrower here, yeah. So we create a method which accepts the borrower, yeah. And now we need to tell what are the results. Yeah, there are many ways you can assert side effects. But I always stick very close to the idea of the example mapping and event mapping. So what I do, I express side effects through events. Yeah? There are multiple ways you can produce and publish events, but I bypass the problems with publishing events in an atomic way, at least in the part of the domain model. simply by returning these events. So I'm not thinking about how to publish them yet. I'm just telling, OK, this comment might result in producing some domain events. So what I do now, I'm telling, OK, there are some events. Yeah? So let's create it. OK. And then start project by borrower doesn't return domain events yet. So let's make start project by return domain events. OK, yeah, there is no, yeah, it won't work, but we might get there later on. And now we want to assert that some event happened. Yeah? So we might say that has occurred event of type here. OK, and we are telling, for example, that project is started. Yeah? And I created. Actually, project started might be a record. Oh, okay. And here, OK. So let's add a class of the type is here just that. We'll probably need to have a generic type. OK. And then we assert that it returns some boolean. So event occurred. Yeah. Let's change it here. OK. And then we assert event occurred. We can use, for instance, also J. Anything actually would work well. Yeah. So that's something which should at least compile now. Naturally, it won't pass yet, but that's the case with test-driven development. It should be always read. So then we might start doing stuff to actually satisfy just this example. Yeah. So we go with small steps. So if we say that start project by should return domain events which contain something, what we can do is we simply tell, OK, so we actually, what we want to do is to return some new domain events here, right? And then tell that there is always project started added here. Yeah, so that might be very, very simple, just supporting this one event. Yeah, kind of naive, but you will see a bit more elaborated cases here. And then we might have the has occurred event of type when this event, for instance, is instance of the given type. Or maybe let's go with some lists events here. Might be probably a better idea. So yeah. Yeah. And then something like, I don't know, stream any match type is instance, for example, something like that. Yeah. OK. So let's run again. Yeah, and now it's running. Yeah, we faked the system a bit, yeah, but the idea is I wanted to show this very initial step only to show you that we had nothing, literally nothing, not a single line of code. And we started with the heart of the software, with the domain. Not with application layer, not with APIs, not infrastructure stuff. We started with everything that matters. Yeah? The rest is just a way to let you invoke commands on the domain or run some side effects on external systems. But by starting with this, we can start iterating, adding more and more examples, and more and more and more examples, and our code will start to be more generic with each concrete example. Yeah, we don't have much time, about 20 minutes, so that's why I'll move fast forward to the next commits and show you how the process might look like later on. So first, maybe let's clean stuff. Okay. OK. And I'm having a history of commits here. So let's see how the first step might look like. It's actually something very similar to the case you just saw. The idea is it's a bit more descriptive. So it's explicitly says given adult borrower and borrower is not started project, and the project started successfully. And I am using some DSL skills. So I'm not calling constructors directly. Because of two reasons. The first reason is I want the body of my test to be actually written in business language, so you can show it to anyone, not just the description, like here, yeah, actually the body. So that's why I said any adult borrower. I usually start with very simple functions, object matters, then I go to the test builders if there is a need. But the idea is I include only stuff which is important. Then I say, for instance, borrower wants to start a project, and then I'm up to some stuff and assert that some event happens. So that would be the first step of the first example of starting a project by an adult borrower. Then we go to the next step. Yeah, we are still iterating with code. We started with some example mapping on the board, on the whiteboard, and then we dig deeper into more and more examples. Yeah. So now we actually need to have some logic in our system, right? Our system doesn't have any logic yet. So what we do is after having the adult borrower, we say, okay, that's fine. But then there is another case. Given borrower who is 17 years old, when borrower wants to start a project, then project is not started. Yeah? So we say, okay, so when a borrower of age 17 years old, when borrower also start a project, then we assert that no events occurred. Yeah, there's a new method added here, and these tests actually pass. I'm just running them to show you that we might have a quite nice reporting thanks to the description we've just made. Yeah, so it's starting a project case and then given adult borrower and given borrower who is 17 years old. Yeah, so also quite nice language here. Again, to the next step, and now we start refining changes. So we are not telling just 17 years old, but we want to tell, okay, it should also be for anyone below 18 years old. Yeah. Imagine the age is only expressed here as a simple integer. So we are just using parameterized test. That's the next iteration of it. Yeah. So when we run it, then we will have a lot more cases here. So given borrower who is 18 years old, when it's 17, 16, 8, 4, 2, 1, and it should also work. And actually, when you are having some start project by borrower, you can see there is first if here, which checks whether the borrower can be accepted. And so the code will emerge according to the examples written as tests. Okay, to the fourth step here. The fourth step actually has just a minor refactoring, so I'm not going to discuss it here. But the step number 4, the fifth step, is actually kind of interesting because I marked it as the first breakthrough. Yeah? The first breakthrough of our experiments. We started with something very naive, and then we might start thinking when we are writing all these examples, working on the heart of the software, that do we even want to have borrowers which are not adults in our system at all? It's an investing platform, right? So our change in thinking is that we don't want to allow such users in our system. So instead, we moved. We allow anyone actually to start financing a project, anyone who is our user of the system, but we limit who can register to our system. And that's the first change. So that's why I created something like new borrower registers case, yeah, without even going to the board, just by following, naturally following the progression of our changes. And we say, okay, so new borrower registers. And then we start writing concrete examples, like only adult borrower can register their accounts, yeah? And then we say that given birthday and current date, something like that, then we allow or disallow, yeah? So when I run this case, new borrower registers, it actually looks like this here in the report, right? So based on some birthday, we allow or disallow to users to register. An important thing here is that actually quite interesting concepts of the domain appeared, like borrower registry, registration, that kind of stuff, right? So, we might actually go to the next step and not only tell, okay, we are having new borrower like this, just invocation of a constructor, yeah, and based on just on the type. We can do that, but there needs to be something more which actually accept this command. So going farther here, we might see that actually these concepts which were implicit are now modeled explicitly in the next iteration of our changes. So we explicitly have something which is called borrower registry, which can accept requests for users to be registered. There is also some registration form with all the details presented by our new potential borrower. So the code changes. We can reflect these changes actually back on the board if we feel there is a need for it. So I sometimes, if I were to summarize the changes so far, that would be, we actually don't have a case of adult borrowers searching a project here. We have a case that we allow registering or disallow registering some specific users. So that's completely new use case, completely new story here. We can reflect this on the board so we can see it, but it's not always necessary, especially when we are iterating really fast in the very early stages of development. Okay, yeah, so going next, we can actually see some more changes again here in this one. Okay, so by looking at the examples, we again, this one tells a borrower without criminal recourse there's a project, yeah? And again, the same thing. We don't want to have borrowers who have criminal recourse. So that's why we moved again this check to the logic of the registration, yeah? Checking some due diligence of a potential borrower. And ultimately, this leads to quite interesting finding that starting a project is really all about checking the money, not just the money, the total value, the funding goal of the project, yeah? So we are having just one rule about this, about sorting so far in this iteration of the model. So okay when less than 1,000, but need to be verified when more than 10,000, yeah? And when it's okay, the value is, the funding goal is less than $10,000, then the project is immediately started. But if it's more or equal to 10,000, then project is accepted for verification. Some new concepts also appeared in like project proposal supervisor, and it's all reflected from the code. So when we go back again to starting the project examples, we can see we started following the next examples and again started branching our code. So given project proposal of $9,000 of total value, when borrower wants to start a project based on this proposal, then project is started successfully immediately. That's this example. But given project proposal of $10,000 of total value, our funding goal, probably funding goal would be a better name here. When borrower wants to start a project based on this proposal, then project needs to be verified first. Yeah. So we again say that borrower wants to start a project, then we assert that some event happened. Yeah. And now the important thing is we started with the heart of the software. We started with just iterating on the domain model. It's extremely cheap. You can verify it. You can ask other team members what they think about it. You can even ask business what they think about it. Not maybe explicitly on the model, but about the examples, yeah? If we are going in the right direction. And if we have some minimum value expressed directly in the domain code, what we can do is that we can actually start adding all the layers around it. We can start adding adapters, ports, and that kind of stuff. If we want to follow ports and adapters architecture, we can group all use cases. For example, here, start project use case, and then start project use case delegates to the project proposal supervisor. Currently, project proposal supervisor is kind of domain service. We don't necessarily need to find out aggregates yet and do OOP. At this point, we say, OK, we got something which accepts it. And basically, that's all. So this is the primary port, something that executes the code underneath. Here, just by passing it to the domain service. In case of aggregates, that would load the aggregate, execute the comment on the aggregate, and publish events, but make sure that events are saved in the same transaction as changes to the aggregate. Or you might have inconsistent state, but that's completely different topic, actually. So you're having a use case, you're having start project use case, and then you're having a wrapper around it. So you're having, for instance, start project command line interface. That could be a REST adapter, that could be some messaging adapter, it's up to you, it doesn't matter. That's something which simply calls the use case here, right? So, for example, when you're having start project command line interface, you're executing start project use case based on the arguments passed in. And then you can start adding stuff, and then you can start following, writing other kind of tests, integration tests or whatever you call them, acceptance tests. There are different namings. Basically, something that doesn't duplicate the logic. We already had expressed in our examples written directly in domain model, but something which checks whether these parts combine well, whether these parts communicate together. So usually some simpler smoke tests without very sophisticated logic. Yeah, then we might have some infrastructural, like for example some repositories for borrowers, but the most important part is here in the package of the domain, yeah, in the module managing project. That's the one we've discussed so far. Okay, so we are getting to the end of the presentation. So maybe the case with the live experiments I mentioned before, the idea is that you try to run live experiments very similar to the initial experiments, but you try to isolate it as much as you can. When you got nothing, you can go with people, do some mob programming, start hacking stuff, start challenging the model and that kind of things. But when you already have something which is working on, you have some legacy code. What you need to do is you need to take the previous version, wrap it in some maybe bubbling context, it depends how we name it, but the idea is we start in isolation working on it, and we start to change it according to some new findings. And if we can't change it, we can simply copy-paste even stuff. That's not bad in this case. Copy-paste stuff, have, for instance, completely isolated branch on it, and then start changing, starting from the domain model and checking how it behaves. And then ask others what they think about it. If it's okay, we know, okay, we are on a good track. It might happen that we might be ready actually to merge it, but it rarely happens. Usually when we are running live experiment just to find out what are the changes needed to the system. And if we are on the right track, we can start working on a new feature based on the knowledge we accumulated so far. So that's usually a two-step process, but looks very, very similar to the initial experiments. Okay, so thank you very much for your attention. I'm Mike Wojtyna. I'm doing stuff like this, doing domain experiments. I'm a consultant, trainer, and software developer. Recently, I've started my own training program, interactive training program, called howtobe.pro, which discusses domain experiments and everything which is universal to the idea of producing good software and not depends on specific technologies or languages. So if you are interested, take a look at my website. You can join, you can contact me later during the break, or simply mail me or find me on LinkedIn. I would be happy to stay in touch. Thank you very much.